Hello guys, so you learned about substitution technique and we'll look into more advanced substitution technique now. So we'll look into two techniques under that. So under the two techniques, this would be the first one, right? So you can see here that we have an integral dx is in the numerator, right? So in the denominator we have a linear function multiplied with a square root of a quadratic function, quadratic expression. Let's say quadratic linear expression multiplied by a square root of a quadratic expression. So you should have all of this. You can't have anything in the numerator, so there can be a constant. In the denominator, we have a linear function, right? Maybe x is there, right? Maybe only x is there. It doesn't matter. Linear function multiplied by a square root of a quadratic function, right? You should have a quadratic here. Okay, right. So what is the most appropriate substitution in this case? The most appropriate substitution in this case is this, right? So you could see this linear function in front of it. So this is the most appropriate substitution, 1 over t. Right, so 1 over u, 1 over t, whatever it is. Replace this by 1 over t. Right, this is the substitution. Right. So once you did this substitution, then you know you have to get dx by dt or dt by dx. Let's take dx by dt in this case. Right, we derive this with respect to t. So this would be a times dx by dt, a times dx by dt, plus this is 0, this becomes 0, and when you derive it, this becomes minus 1 over t square, minus 1 over t square, right. So from this we can obtain dx is equal to minus dt minus a times dt over t square. This is a substitution. Okay, so you can say that we derive this relationship with respect to time or t, not time, with t. So when you derive it, imagine this is y and this is x, right? If it is y, then we have to put dy by dx. Implicit differentiation. Think about implicit differentiation. Okay. Then there is a constant vanishes. Dx by dt would be here, so I just multiplied by t on this side, right? So after this substitution, then you can change all x variables into t. So for that you have to replace x by t. So ax is equal to 1 over t minus b. Then x is 1 over a times 1 over t minus b. So using this relationship, you can replace all x's there, right? And you can replace dx by this relationship and ax plus b by this relationship, 1 over t. Right? So you don't have to memorize anything, you only have to memorize this. This is the only thing you have to memorize. So whenever your integral looks like this is the substitution, the most appropriate substitution that you can do. Right. So let's look at an example on this. Right. So this is an example. Here you can see this is a linear expression, linear term, square root, and inside the square root you have a quadratic expression. X term is missing, but this is quadratic because of this x squared term, right? So don't try to use t equals square root of this, it will not work, right? So what is substitution? Let me do the substitution here. This guy, replace this guy by 1 over t. So in that case, this will be dx by dt equal minus 1 over t squared. So when you differentiate 1 over t, you get minus 1 over t square, right? For example, if you differentiate 1 over x, let's say y equals 1 over x, dy by dx is minus 1 over x square. Use quotient rule and see. Make mother lazy. You can use quotient rule and see. Okay, then dx can be replaced by minus dt over t square. Next thing we need to replace all x's. So in this case, x is 1 over t minus 1. 1 over t minus 1. Right. So we have wrote everything. Now let's try to do this expression separately, then it will be easy for us. Let's try to do this expression. X squared minus 1 therefore would be 1 over t minus 1 whole thing squared minus 1. Okay. So let's expand this. Then I get 1 over t squared minus 2 over t plus 1 minus 1. These two cancels out. And here we get 1 minus 2t over t squared. I just took the common denominator. This is the expression for x squared minus 1. Okay. I hope it's clear. Right. Now we can replace everything. So this would be dx can be replaced by minus dt over t squared divided by x plus 1 is 1 over t, right? Then square root, inside square root I have 1 minus 2t over t squared. Okay, so from here you can say that t squared can be taken out because it's a complete square, this guy here. So let's put this minus sign in front of it, then dt over t squared. So this becomes 1 over t. From this I can take t squared, but what comes out will be the t. So 1 over t from this t gets t squared. So inside the square root we have 1 minus 2t. You can see why we did this substitution. Now I can see here that this t squared cancel out this t squared. These two cancel out. Now let's see what remains. Minus dt over 1 minus 2t half square. It's a linear expression. It's a linear expression. Then you know how to deal with linear expressions. Bring it to the top. So minus 1 minus 2t to the power of minus half dt. So then the answer is you add plus 1 to it and divide by half. So if you divide it by half, 2 goes to the top, 2, 1 minus 2t half plus integrating constant where c is a real number. Right. So now we can't stop here because we have to replace t by x plus 1, 1 over t by x plus 1. Here we have t. So how do you replace that? To replace it, you can do minus 2, 1 minus 2 times. So what is t? T is 1 over x plus 1. So this is x plus 1 to the power of half c. Right. Okay, so this is the technique that we have to memorize. Right. So you may not need to memorize this because nowadays, I mean, when you look at the trend, usually substitution will be given. So sometimes, I mean, for the last couple of years they didn't give any substitution. But the next technique that we are going to do was given in the exam, the last one, 2021 exam. Right. So I'll give you some questions for you to try now. Right. So try these two exercises and see if you can use this technique, substitution technique, and get to the final answer. So once the substitution is done, you will get an integral that you will be familiar with. I mean, that would set into your models, right? So models we learn. That means it could be one of the standard models, or sometimes you may have to do partial fraction decomposition and get the answers, right? So that can happen. Okay. Next, we look at the last technique that we will learn. Right, guys. So this is the second technique, and second and the last technique we will learn today. And whenever you have this kind of integrals, so you can say that this is an integral of a square root. So what is inside a square root? So here we have a rational function, improper rational function, x minus a divided by b minus x. So they are both linear functions. Notice that they are both linear functions. Okay. Here is a product of two linear functions. product of two linear function, and we have a square root inside of them. So what is the most appropriate substitution in this case? The most appropriate substitution is this: x equal a sine square theta. A could be one of these, right? So let's say this is a sine square theta plus b cos square theta. Right? This is the substitution. Most appropriate one. Then we have to derive this with respect to theta. Right? So dx by d theta a, this would be 2 sine theta, then derivative of sine theta is cos theta, plus this is 2b cos theta, derivative cos theta is minus sine theta. Okay, so from here we can bring 2 sine theta cos theta in front, factor out them. So 2 sine theta cos theta, then a minus b. So what is this? 2 sine theta cos theta means sine 2 theta. So a minus b sine 2 theta. Okay, so dx by d theta is a minus b sine 2 theta. So if it is dx, then this is equal to, we have d theta term as well. d theta. Then dx by d theta තමයි මේකමයි ආවේ. මම d theta වලින්ම multiply කරලා ලිව්වා අපිට ලේසි වෙන්නේ. dx කෙලින්ම replace කරන්න පුළුවන් එතකොට. එදා මේක. Right. Okay, then let's take this expression. Let's take this expression and see what we'll get. X minus a. If we do this one, what do you get? X minus a. So a sine square theta plus b cos square theta minus a. So when I combine these two, I get a sine square theta minus 1 plus b cos square theta. So what is sine square theta minus 1? If I bring minus 1 in front, if I factor out a minus 1, it becomes 1 minus sine square theta. 1 minus sine square theta means cos square theta. This will be minus a cos square theta plus b cos square theta. Right. So now I can factor out cos square theta. Then I get b minus a. Cos square theta, b minus a. Right. So similarly, b minus x. B minus x would be, so try this on your own. This would be sine square theta a minus b. B sine square theta a minus b. So it should be b minus a as well. Yeah. Let's see. Right. So when you do this, you will get an expression like this: sine square theta b minus a. Now we can use these two to replace this because we have dx, that is this. Then x minus a is this, b minus x is this. Right. So let's substitute all of these and see what we get. So I'm considering only this one. Right. So this is, you can use the same model to deal with this integral as well. Right. So I'm going to use this one only. Right. So x minus a can be replaced by this. B minus x can be replaced by sine square theta b minus a. Then dx, how can we replace dx? So we found dx to be a minus b sine 2 theta d theta. 2 theta d theta. Okay. Now these two cancel out. Right? Cancels out. Cos square theta, sine square theta, that means cot square theta. If you take the square root, you get only cot theta. So we have cot theta here. So let me expand this one as well. A minus b, you can bring it in to the front. Then sine theta is 2 sine theta cos theta d theta. So cot theta is actually, let me replace it by cos theta divided by sine theta. Now we can see that sine theta cancels out. Then we bring 2 in front, a minus b. This would be cos square theta d theta. Right. Now we know how to solve this one. How do you solve this one? 2a minus b. This is 1 plus cos 2 theta over 2 d theta. Right. Okay. So this will be 2 cancels out. A minus b. When you integrate 1, you get theta. When you integrate cos 2 theta, you get sin 2 theta divided by 2 plus integration constant. Now we have to replace theta and sin 2 theta divided by 2 in terms of x variables. Now let's do that. Right. So notice here we found this one already. X minus a is equal to cos square theta plus into b minus a. So we can use this to get an expression for cos theta. Right. Then after that for theta. So this is cos theta, root x minus a divided by b minus a. So from this also we can take a value for theta, because theta can be replaced by cos inverse square root of this one. Similarly, we can have b minus x term was equal to b minus a times sin square theta. Similarly, we can write this expression as well. So you can use either one of them. So finally, we could write a minus b. Theta can be replaced by one of these, cos inverse. So let me take this one. So cos inverse theta must be equal to cos inverse of this square root of x minus a divided by b minus a. Then plus sin 2 theta divided by 2. Sin 2 theta is 2 sin theta cos theta. When you divide it by 2, 2 cancels out. Then you have sin theta into cos theta. So sin theta into cos theta is this square root of x minus a into b minus x. When you multiply these two, and these two will be multiplied and become b minus a. Right, so this is the final answer. You can see it's a long one. Right. Okay, so it's very rare that you would see these types of substitution, but there was a question like this in the last paper. So right, so that's why I told you this one as well. Okay, now let's look at an example where example on a definite integral which uses substitution technique. Right, definite integral that uses substitution technique. Right, so I will only do 1 or 2 examples. Then you should learn how to do that. Right. So let's start with a simple problem where you can learn the procedure. Right. So you can learn the procedure on this. Now this can be done. This can be done without using substitution. Right. No argument there. But let's try to use substitution technique. So I can replace this by a simple variable. Then it would have this format. Right. So what is that? That would be, substitution would be u equals 3x plus 1. Then du by dx would be 3. Right, that's a substitution. Now this is a definite integral. Now what will happen? What do you think? You have a lower limit and an upper limit. Lower limit is 1, upper limit is 2. When you change variables, these limits also change. When you change variables, the limits will also change under substitution technique, not in other types of integrals. For example, integration by parts, limits will not change. You can carry out the limits until the last step. But if you have to use a substitution in the middle, then limits will change. Right. So how do you get the new limits? So use a table. It's very easy if you use a table, small table. Put x here, original variable, and the new variable. When x is equal to 1, what will happen? When x is equal to 1, put 1 here. 3 times 1 plus 1 is 4. When x equal 1, you will become 4. Or you can write this here as well. 3x plus 1. And then this guy 2. When x is equal to 2, 3 times 2 plus 1 would be 7. Okay. Now we know everything we need. Therefore, first change the limits 2 to 7. Now, 4 to 7. 4 to 7. U goes from 4 to 7. 3x plus 1 is u raised to 4. Dx is du by 3. So if I take 3 outside, so 1 over 3 outside, then this would be u to the power of 4. 4 to 7, u to the power of 4 du. So 1 over 3rd, when you integrate this one, you get u to the power of 5 divided by 5. So remember this 4 to 7, right? Okay, this is the integral. Make ongolo ganna thala danna. ඊට පස්සේ evaluate කරන්න ඕන. How do you evaluate? Write the limits. Square bracket එකක් දැම්මා. Put the square bracket and write these limits 7 and 4. Right. So 1 over 3rd මෙන්න මේ constant එකක් denominator එක තිබ්බොත් denominator එකේ constant එකක් තිබ්බොත් you can factor it out. So when I factor it out, you get 15 instead. 15, right? Then put it like this. First, replace u by 7. So 7 raised to 5. 7 raised to 5. Then put minus, replace u by 4. 4 raised to 5. Right. So this is the answer. So notice here under definite integral, you don't put integration constant. You will get an output like this. Make I think mama evaluate කරන්න යන්නේ නැහැ. මේක ලොකු ගාණක් හින්දා සාමාන්‍ය කළ විභාගෙන්නේ පොඩි ගණන් තර කෙලින්ම evaluate කරලා දාන්න පුළුවන්. So let's look at another example now. Right. Okay, so this is a product of a sine and sine with the cosine function of the same argument, right? So sine's power of sine function is odd. We have odd power, and for cosine you have an even power. So since it has a odd power, I'm gonna take 1 from this and write it next to dx. So I have to do this thing only once. So this becomes sine squared x, cos squared x. Then I separate sine x from this and write it next to dx. So sine x dx. I have to write the limits 0 to pi by 2. 0 to pi by 2. Write the limits until you make the substitution. Right? So until you evaluate it. Actually, you have to carry out the limits. Right? So in the middle, if you use substitution, then you can have to change the limits as well. Okay. Next, change all sine squared sine functions into cosines. Right? So if you separate out the sine, change all sine functions to cosine. Do it again, pi by 2. So sine squared can be written as 1 minus cos squared of x. Then cos squared x, you leave it like that. Then sin x dx. Okay. Right. Now we'll make the substitution. What is substitution we use? We use the substitution u equal cos x. U equal cos x. Then du equals minus sin x dx. Alright. So du by dx is actually minus sin x. I cross multiply it and wrote it here. Then I have to change the limits as well. How do you change limits? Put x here, variable x to u, right? Variable x to u. Now, when x is 0, u is cosine of x. Cos of 0 means what? Cos of 0 is 1. When x equal pi by 2, cos pi by 2 is 0. You can see how the limits change. Now we can change everything. Now when you change everything, you have to change the limits as well. Now here you can see that 1 to 0. We start from 1 and ends up at 0. This will be 1 minus u squared. This is u squared sin x dx. You can see that is negative du. Negative du. Okay. Right. So I put this negative sign inside. 1 to 0, then this will be u squared minus 1 into u squared du. Okay. Then I can expand this out. 1 to 0, u4 minus u squared du. Right. Okay. Now we can integrate separately. If you integrate u to the power of 4, you get u5 divided by 5. Don't forget to put the limits 1 to 0. Always put the limits. Then you have a minus sign. When you integrate u squared, you get u3 divided by 3. 1 to 0. That's it. Right. Now what do we have? I can factor out this constant 1 over 5. Then I put 0 raised to 5 minus 1 raised to 5. 1 raised to 5. Then put minus 1/3, 0 raised to 3 minus 1 raised to 3. Right. So what is the answer? From here we have minus 1 only. So minus 1 over 5th. From here we have plus 1 over 3rd. So 1 over 3rd minus 1 over 5th would be 2 by 50. Right. Correct. 1/3 minus 1 will be 5 minus 3 divided by 50. Okay. Right. So you can see here that this is the only thing you learned about definite integers. You learned about it already. So that's why I didn't start with it. The introduction was given already in the live session. So I showed you how to use how limits are changing. How limits are changing under definite integers when you use this substitution technique. අනිවාර්යෙන් limits change කරන්න අමතක කරන්න එපා substitution technique එකේදී. අනිත් ඒ වගේ අවශ්‍ය නැහැ. අනිත් ඒ වගේ definite integers එක මෙන්න මේ වගේ දැම්මම හරි. මේ වගේ නිකන් දාලා ඉවරලා දීලා තියෙන limits ටිකම දැම්මම හරි. නමුත් substitution එක පාවිච්චි කරන්න ආවම අනිවාර්යෙන් limits බලන්න. lower limit එක කීයටද යන්නේ? So lower limit x equals 0, lower limit is replaced by 1. Upper limit 5 by 2 is replaced by 0. ඉතින් ඒවා හරියටම lower limit upper limit මොනවද කියලා බලලා කරන්න ඕනේ. Okay. Right. So thank you for watching.